this video, we will explore chunking in natural language processing.
Okay, but what is chunking?
Chunking is an essential technique used to extract meaningful phrases from text by analyzing its structure. By the end of this video, you will understand what chunking is, how it works, and its real world application. Chunking is also known as shallow parsing. It is a process in NLP that helps identify phrases within a sentence by grouping words based on their part of speech tag. As defined earlier, short phrases refer to the phrase formed by including any of this part of speech. Chunking can be done to identify, thus, group noun phrases, adjective phrases, or verb phrases. Chunking relies on POS tagging, which labels each word as noun, verb, adjective, or other grammatical category. This allows NLP system to recognize key pattern in text efficiently. For example, consider this sentence: I had burgers pastries for breakfast. Chunking help extract noun phrase like burgers and pastries. Regular expression or regex are powerful tool used in text processing to define pattern and extract specific substring. To implement technique like chunking in NLP, understanding regex is essential. On the right side of the slide, we will see a donut chart explaining three important regex quantifiers. The asterisk means that the preceding character can appear zero or more times. For example, in the pattern AB, the letter B can appear any number of times, so it matches A, AB, A, B, B. The plus sign indicates that the preceding character must appear at least once. In AB plus, the letter B must be present at least once, so it matches AB, ABB, or ABBB, but not just A. The question mark means that the preceding character is optional and can appear at most once. For example, in case AB question mark, the B can appear either once or not at all, so it matches A or AB.
Okay, but how exactly chunking works?
Chunking involves three main steps. First, tokenization. The first step is tokenization, where a sentence is broken down into individual words. This helps in analyzing text in a finer level. Step 2 is POS tagging. Next, we perform part of speech tag, where each word is labeled based on its grammatical role, such as noun, verbs, adjective, and so on. Step 3 Chunking. Finally, in chunking step, words are grouped into meaningful phrase based on predefined pattern. For example, noun phrase or verb phrase can be extracted using regex and POS tag. The code snippet at the bottom demonstrates this process using an LTK library in Python. Here the text is first tokenized, then the POS tagging is applied using nltk.post tag text. This is a crucial step in many NLTK applications. Now let's dive into the chunking implemented using Python NLTK library. On this slide, we will see a code snippet demonstrating the use of regex parser for chunking and a corresponding parse tree on the right. Understanding the code, first we import regex p parser from NLTK chunk module. Next, we define a chunking pattern using a regular expression as we have done in the previous slide. In this case, we specify the rules for extracting noun phrase and verb phrase. Here, the pattern predefined is made up of determiners, singular or plural noun, and optional words in between them to form noun phrase. Finally, we call chunker.parse, passing in list of words with their POS tag to apply our chunking rule. Next, let's interpret the parsing tree. The right side of the slide shows a syntax tree generated by chunking. Here, we see the sentence, the book has many chapters structured into meaningful group. Two noun phrases are identified, which are the book and many chapters. The verb has is positioned separately as a verb phrase.
You have been talking about tokenization all this time. Actually, is tokenization? Can you just explain me with some example?
Tokenization process breaks a sentence into individual words. As you can see here, we have a sentence: the quick brown fox jumps over the lazy dog. By doing tokenization, the sentence can be broken down into words like the quick brown fox jumped over the lazy dog.
Okay, and what is POS tagging?
By POS tagging, I mean that each word is labeled with its grammatical role. For example, here, the is the determiner, quick, brown are adjective, fox is a noun, jumps is a verb, and over is a preposition.
Okay, but what could be the regex pattern over here?
Here we are predetermining a noun phrase. The regex pattern for a noun phrase is a determiner followed by zero or n number of adjective and followed by noun. And the noun, it means we should have at least one noun to finish our regex pattern. This is a parse tree for our example which we have seen in the previous slide. This is the code we have implemented for our chunking example. You can quickly see the steps which we have performed.
I have been coding a lot using NLTK library. Is there anything else or any other library which we can code with?
Oh yes, there is. There's a library named Spacey which I use. It is efficient and accurate.
NLTK is more customizable, but yeah, slower.
You know, Spacey is built in with pre-trained model.
NLTK is not available by default.
Spacey is pre-trained and fast.
NLTK requires additional setup.
Spacey is supported.
NLTK support is not that available.
But you know what? The WordNet is not built in.
Okay, NLTK has a strong support.
This classification by using Spacey is optimized for deep learning.
NLTK has a traditional ML based model.
Custom model using Spacey is supported with fine tuning.
Okay, fine, NLTK is limited.
So, in contrast, Spacey is similar to NLTK as a service, but it helps you to get specific tasks done.
And NLTK is built by scholars and researchers as a tool to help you create complex NLP functions. It almost acts as a toolbar of NLTPK. Okay, so can you give some real world application where actually this chunking is used?
Yes, I can. First application of chunking is information extraction. When analyzing large amount of text, we often need to extract specific words or phrases related to our area of interest while ignoring unnecessary detail. Chunking helps in this process by grouping relevant phrases and filtering out unimportant words. The next application of chunking is question answering system. Question answering system relies on paragraph chunking to break down large document into meaningful sections. This technique is particularly useful for document summarization and retrieval specific answers to user queries. The next application is customer feedback analysis. Business receives large volume of customer feedback through review, surveys, and comments. Clustering helps them analyze the data by grouping similar feedback together, making it easier to identify common theme or recurring issue. The next application is legal and academic research. Legal and academic research involve analyzing complex documents such as legal contract, research paper, and policy document. Text segmentation help breaking this document into structured section, making it easier to understand their arguments and key insights. Chunking is a key NLP technique that groups word into meaningful phrases, improving text analysis. As NLP advances, chunking remains essential for structuring and interpreting text. Concluding this slide, I hope you have understood the key concept of chunking.
Thank you.